Hi guys, I'm back again for video 2 of acid-base titration curves. This time I'm going to do just an example before I get into the weak acid and strong base titrations. So this problem just says how many milliliters of a 0.085 molar NaOH solution are needed to titrate to the equivalence point. So needed to reach the equivalence point. With a, let's see, we'll do 35, no, we'll do 40.0 milliliters of a 0.0900 molar HNO3. Okay, so we know that we can use NB equals NV for everything, and normality is molarity times the number of H's or OH's. So in this case, for my NaOH, I have 0.0850 molar, and I have 1 OH, and I want to know the volume. And for my NH3, I have 0.09, I have 1 H, and I have 40 milliliters. And I'm just going to leave that in milliliters. So 0.09 times 40 divided by 0.085. I got 40, let's see, that's got 3, they have 3, so 42.4 milliliters of NaOH are needed. So if they just ask you how many milliliters are needed to titrate it to the equivalence point, that's pretty easy. All right, now we're going to do an example where we are going to be titrating a weak acid with a strong base. And in this case, I'm going to have 35 milliliters of a 0.150 molar acetic acid, so HC2H3O2, and I'm going to titrate this with a 0.2 molar NaOH. Alright, and we're going to do it before any base added. We're going to do it when we have added 15 milliliters of NaOH. We're going to do it when we've added 26.25 milliliters of NaOH. And then we're going to do it when we've added 35 milliliters of NaOH. And while I'm on this page, I'm going to find my moles. So 0.150 is moles over 0.035. Okay, and that's going to be the molarity, or the moles, that I'm going to use in my ice chart for my acid. Okay, so for part A, I haven't added any base. So all that I have is a 0.125 molar. Nope. Wrong one. I have 0.150 molar HC2H. Just messing this all up. HC2H3O2. Okay, so I haven't added any base, so that's all that I have is a weak acid, and they want me to find the pH. I know how to find the pH of a weak acid. So generally, we did HA for a weak acid. And this is going to require an ice chart because for a weak acid, I don't know how much ionizes. And then I'd have to set this equal to Ka. So for acetic acid, that's 1.8 times 10 to the negative fifth. I'm going to assume X is really small. Okay, so that's X, and according to my ice chart, X is my H plus. So to find my pH, negative log of that number, 2 point, and that looks like I'm having 3 significant figures, so 3 decimal places, 2.784. So that would be a good pH for a weak acid. All right, we'll go on to B. So B now, I'm going to add some base. So I'm going to have HC2H3O2, and I'm adding a base. I'm going to make water and a salt, which is NaC2H3O2. Okay, and in my ice chart, I'm going to need to put my moles, and I already found the moles of the one, 0.00525. And now I need to do it for the NaOH. So for my NaOH, I'm using 0.2 molar, and I'm going to add 15 milliliters. So 0.2 is moles over 15, so 0.015. 0.003. All right, so between those, this is the smallest. All right, so I am left with a salt and a weak acid, and they contain a common ion. So that means this is a buffer. And if I have a buffer, I can use my Henderson-Hasselbalch. So pH is pKa, so negative log of my Ka. This is going to be the same Ka that I just used in part A, plus the log of my conjugate base, and I can put my moles in here, 0.003 over 0.00225. So negative log of 1.8 to the negative fifth plus the log of 0.003 divided by 0.00225. So I got a pH of 4.870. All right, so the pH went up a little bit, which we would expect from adding an acid to it. Okay, then for C, it's going to be the same equation. Alright, and I still have my original amount, which was 0.00525, so 0.00525, and I still have 0.2 molar, but now I'm adding 26.25, so 0.02625. So they're the same number, so it doesn't matter which one I subtract because they're the same. Okay, I am at the equivalence point because I have no acid or no base left. All I have left is this stuff. And this is made of a strong base and a weak acid, which means I have a basic salt. So since it's a basic salt, I'm going to use BOH. Requires another ice chart. Okay, but in here I have to use my molarity. So I'm going to take my moles, which I had 0.00525, and I have to divide by my liters. So I have 26.25 plus the 20 milliliters that I started with. How much did I start with? 35. So 35 milliliters plus the 26.25 is 61.25. So 0.06125 liters. So my molarity is 0.0857. Okay, so since this is a base, I'm going to have to set this equal to KB, but I'm going to have to get the KB from my Ka. So 1.8 times 10 to the negative 5th times KB is 1 times 10 to the negative 14th. Okay, so then KB is equal to x squared over 0.0857 minus x. We're going to assume that's really small. And I would say x is really small because it's to the negative 6. And according to my ice chart, my x is my OH. So this is my OH minus. So I can find POH by doing negative log and then I can find my pH. So 14 minus that number. Okay, so my pH continues to rise. Last time it was 4.87, now we're at 8.839 at the equivalence point. Alright, so we've done, before anything was added, we've done 15 milliliters, 26.25. Now we'll go to 35 milliliters. Good thing is it's the same equation every time that we're using for all the parts. All right, back to moles. So this is 0.2 moles over 35 milliliters. So 0.007, don't care about water. Now this one's smaller, 0.00525. .00175. Okay, so I have a basic salt, which I don't really care about because I have a strong base. And I don't have a buffer because it's a strong base. So my molarity is my moles. And I had 35 of the acid and 35 of the base, so that's 70 milliliters. All right, and if this is a strong base, then that means that's the molarity of my OH minus because all of it separates. So then I can find my POH by doing negative log. So 1.602. And then I can find my pH. So 14 minus that number, 12.380. So again, my pH went up because I was adding more base. So in this one problem, if we go back to the beginning, in this one problem, we have done a weak acid, then we did a buffer, then we did a basic salt, and then we did a strong base. So you can see how all of these parts that we've had from chapter 15 with equilibrium to chapter 16, which is how we had like strong acids, strong bases, weak acids, weak bases. And then 17, we incorporated buffers and salts. All of that is now coming together in this one section. So that's what makes this one section so much stuff, is because everything's finally come together. All of that stuff is, as you can see in this one problem, all the pieces that we've had. So that one is weak acid with a strong base. That's the second video. And on our third video, we'll do the very last one that we're going to look at. So that's it for now. Bye.